Step-by-step breakdown. The starting point. Quantum superposition. We begin with the entire universe, a quantum system. For example, a particle and its environment. Everything else, like air molecules or light. This combined system and environment is in a specific quantum state, which we can call psi SE of t. This state is a superposition. The system is in both state S0 and state S1 at the same time, and each of these states is entangled with a different state of the environment, called E0 of t and E1 of t. In simple terms, the which path information of the system has been copied into the environment. 2. The full picture, the density matrix. To analyze this, we convert the state psi SE into a more powerful object called the density matrix, pronounced rho SE. This matrix contains all the information about the quantum state, including the strange or unusual superposition effects. 3. Focusing on the system, the partial trace. We do not care about the entire universe. We only want to describe the system called S by itself. To do this, we mathematically average over or ignore the environment called E. This mathematical operation is called taking the partial trace, written as trace sub E. The result is the reduced density matrix for the system alone, called rho S of t. 4. The crucial part, the emergence of classicality. When you calculate rho S of t, you get 4 terms. 2 of them are called the diagonal terms. Absolute value of C0 squared times ket S0 bra S0, and absolute value of C1 squared times ket S1 bra S1. These represent the classical probabilities of finding the system in state S0 or in state S1. The quantities absolute value of C0 squared and absolute value of C1 squared are just like the probabilities in a coin toss. 2 off-diagonal terms, called coherences. These terms, for example, C0 times C1 star times ket S0 bra S1, are responsible for all the quantum strangeness, such as interference. They are what make a quantum superposition different from an ordinary classical mixture. The key insight: each of these quantum weirdness terms is multiplied by an important factor called the environmental overlap, spoken as bra E1 of t ket E0 of te. 5. The process of decoherence. As the system and the environment interact, the environment states called E0 of t and E1 of t, which are correlated with the different system states, become more and more different from each other. In quantum mechanics, different has a very specific meaning. It means orthogonal, like 2 vectors that meet at a right angle. The overlap between 2 orthogonal states is 0. Therefore, the quantity spoken as bra E1 of t ket E0 of t goes to 0.